Can you believe that an old, battered car, seemingly worthless, can actually become a mobile gold mine that helps industry tycoons pocket billions of dollars? To transform waste into a vast fortune, this industry puts end-of-life vehicles through a brutal dismantling journey. From isolating their critical power systems and draining every hazardous fluid to unleashing terrifying mechanical shredders that tear through layer after layer of metal. How does this remarkable transformation unfold within a closed-loop system, and what massive machines are driving the entire process? Join Factron Process as we press the start button and uncover it all in today's video. Every year, more than 25 million end-of-life vehicles are collected, making automobiles the most recycled consumer product on the planet, far surpassing aluminum cans and old newspapers. This explosive growth has transformed primitive scrapyards into a vast circular economy worth more than $100 billion. The clearest example begins with a car purchased for $48,000. After 10 years on the road, its practical value may have disappeared, but the value of its raw materials begins an entirely new and unexpected chapter. In fact, a 1-ton automobile contains up to 75% ferrous metals and high-grade alloys. Recycling this steel can reduce energy consumption by as much as 74%, while also significantly cutting CO2 emissions compared with extracting and processing virgin ore. As a result, hundreds of millions of tons of material are brought back to life every year, continuing their journey in the form of buildings, everyday products, and even the next generation of automobiles. When a vehicle reaches the end of its life and passes through the gates of a recycling facility, its official decommissioning journey begins with a document inspection, followed by the recording of its vehicle identification number, engine number, and overall condition. The first mechanical step is the removal of the license plates. They are fed into a cutting machine and destroyed to completely eliminate the risk of counterfeiting or illegal reuse. Next, technicians carry out a rapid assessment to classify the vehicle. Components that are still in good condition, such as the engine, transmission, and electronic parts, are removed separately and resold through the multi-billion-dollar used auto parts market. Severely damaged vehicle bodies, on the other hand, are arranged into orderly batches and held for transfer to the scrap shredding line. Thanks to this rigorous process, more than 95% of end-of-life vehicles in the United States are successfully recycled, making the automobile one of the most extensively recovered and reused consumer products in the world. Immediately after sorting, the vehicle's power supply must be completely isolated to prevent fires or explosions inside the shredder. For conventional gasoline or diesel vehicles, workers use insulated cutters to disconnect the negative cable first, then the positive cable, before removing the lead-acid battery and placing it in a leak-proof tray. In the United States, this type of battery has a recycling rate of up to 99%. Removing an EV battery is a life-or-death operation. Even a small mistake that leaves a battery behind or damages it can cause a bomb-like explosion inside the shredder. One example was the catastrophic explosion at David's Recycling in the United States in March this year. The blast was powerful enough to throw workers to the ground, set 10 to 15 vehicles on fire, and create a thick column of black smoke that shut down nearby US Highway 54. Once the battery has been removed, the vehicle is raised onto the tilting lift of a specialized depollution station. Massive hydraulic clamps lock the chassis firmly in place, while a vacuum system extracts all refrigerant from the air conditioning unit to protect the ozone layer. Next, technicians open the drain plugs and allow the engine oil and transmission fluid to flow out under gravity. The mechanical highlight is the fuel tank drilling and extraction unit. It uses an ultra-hard copper beryllium alloy drill bit to pierce the bottom of the steel fuel tank without producing a single friction spark. In just 10 to 12 minutes, all 8 operating fluids, including brake fluid and coolant, are completely removed through a sealed system and transferred into secure underground storage tanks. Despite its speed, this process recovers an enormous volume of resources. Each year, a major network such as LKQ collects more than 885,000 gallons of used oil and nearly 2.38 million gallons of fuel, enough to power a fleet of tow trucks around the Earth hundreds of times, while significantly reducing energy costs across the entire facility. Once all fluids have been drained, the vehicle moves to the main component removal area. Here, a multi-socket pneumatic tool removes all 4 wheels simultaneously in just a few seconds. Each wheel assembly then enters a hydraulic tire removal machine, where a pair of wedge-shaped press blades applies up to 11,240 pounds of force to separate the rubber bead from the rim without scratching it. A hydraulic hook system then grips deep into the tire bead and pulls out the thin steel reinforcement wires. Finally, the steel and aluminum rims are sorted separately and sent directly to metal processing plants. The used tires, a type of waste that is extremely difficult to decompose, are fed into a twin-shaft shredder. 2 interlocking alloy steel shafts rotate in opposite directions under maximum torque, tearing and cutting the tires into fine rubber strips smaller than 0.16 inches. This material is then refined for use in asphalt roads, shock-absorbing playground surfaces, or as an alternative fuel for industrial furnaces. The windshield and side windows are cut free from the vehicle body using an ultrasonic oscillating wire cutting tool, which moves rapidly along the polyurethane adhesive seam before the glass is lifted away with large vacuum suction cups. The doors, trunk lid, and hood are then removed one by one. Slightly dented door frames are straightened and sold to repair shops, while severely damaged steel or aluminum sections are sent directly for melting. Inside the cabin, workers continue by removing the seats, dashboard, and floor carpeting for sorting. The main wiring harness, which contains valuable copper cores, is pulled forcefully from the vehicle body and fed into a shredding and stripping machine that removes the polymer insulation and releases clean copper strands. Finally, the foam padding, plastics, and interior fabrics are shredded and recycled into new wheel arch liners or sound insulation materials. Once the cabin has been emptied, a lifting table is positioned beneath the vehicle to lower the entire engine and transmission assembly. Units that remain in good condition are cleaned for reuse or refurbishment, while severely damaged ones are dismantled to recover iron, aluminum, and copper. Beneath the vehicle, the catalytic converter is cut away separately so that rare precious metals such as platinum, palladium, and iridium can be recovered through specialized metallurgical processes. Once the engine assembly has been removed, the remaining vehicle body enters the pre-processing area, where the last stubborn, non-metallic contaminants are stripped away. Here, a massive excavator fitted with a 360-degree rotating hydraulic grapple takes over, converting extreme hydraulic pressure into tens of tons of mechanical gripping force. The machine works with brutal power. Its steel jaws open wide, clamp down, and tear away any remaining doors, rip out the bent exhaust system, and crush the radiator within seconds. Large plastic panels and non-metallic foam padding are shredded on the spot, clearing the vehicle shell many times faster than manual dismantling. This rough cleaning stage acts as a critical filter, removing flammable contaminants early and protecting the main shredder. Within just a few minutes, the once bulky structure is stripped clean and ready to enter the compaction machine safely. Once the vehicle shell has been thoroughly cleaned, the bare steel body is fed into the mouth of a massive hydraulic press to reduce its volume. Under the crushing force of up to 200 tons from the main pistons, the hollow structure, more than 4 meters long, is buckled and flattened, reducing its volume to just 1/10 of its original size. Depending on the technology used at the facility, this mechanical process is carried out in 3 main ways. The first uses a car baler, whose pistons compress the vehicle frame from 3 independent directions, forming it into a dense cube-shaped steel bale that is easier to stack and transport. The second method uses a car crusher, with a hydraulic platen pressing straight down from above to flatten the vehicle into a thin slab only a few dozen centimeters thick at extremely high speed. The final method combines baling and shearing, compressing the body while vertical blades cut it into shorter sections that can be fed directly into a smelting furnace. One interesting technical fact is that after baling, the entire bulky structure of a 4-seat sedan can be reduced to roughly the size of a household refrigerator. Once compacted into dense steel bales, the material is fed directly into a high-capacity shredder, the mechanical heart of the entire line. Inside its heavy-duty hammer chamber, a massive rotor spins at extremely high speed, driven by a 7,500 kilowatt electric motor equivalent to 10,000 horsepower. Dozens of cast manganese alloy steel hammers, each weighing 180 kilograms, strike the metal head-on, tearing and smashing the solid mass into uniform, fist-sized fragments within seconds. The violent impacts thunder through the chamber, and in an instant, the bulky vehicle is completely chewed apart. The machine delivers an astonishing throughput of 100 to 150 tons of steel per hour, equivalent to hundreds of vehicles disappearing every day. In this way, entire mountains of scrap are rapidly transformed into clean raw material, ready for melting. The journey of automotive recycling now enters its brilliant metallurgical core. Clean shredded steel is poured directly into an ultra-high power electric arc furnace. 3 massive graphite electrodes are then lowered into the furnace, releasing an immense electrical current of up to 80,000 amps. This creates a blinding plasma arc like artificial lightning, with a core temperature exceeding 10,800 degrees Fahrenheit, rapidly melting the solid scrap into a pool of liquid metal at more than 2,900 degrees Fahrenheit. During the melting process, quicklime and dolomite are added to combine with oxidized impurities, forming a thick layer of foamy slag that floats on the surface of the molten steel. This slag acts as a protective shield, preventing the liquid steel from absorbing gases from the air while helping the furnace retain heat. Sensors and spectroscopic analysis systems continuously monitor the process to ensure that the alloy composition meets the required specifications. Finally, the glowing stream of molten steel is tilted into a ladle furnace, where precise amounts of alloys such as manganese and chromium are added, preparing it to be reborn as high-quality, new steel billets. After refining, the glowing molten steel is poured into a tundish to stabilize the flow before entering a multi-strand continuous casting machine, or CCM. Here, the molten steel passes through a copper mold, cooled by circulating water flowing at 12 to 15 meters per second. Its outer shell solidifies almost instantly to a thickness of several millimeters, while the core remains molten. A continuous roller system draws the strand downward and guides it into a fine, high-pressure water spray chamber, where it gradually solidifies from the outside inward. At the end of the line, an automatic oxy-fuel cutting machine clamps the glowing steel strand and cleanly cuts it into standard solid square billets, measuring 130 by 130 millimeters. Each billet is several dozen meters long and can weigh several tons, ready to begin the next stage of its journey, being rolled into new construction steel. Once the solid steel billets have been cast into precise square sections, they are immediately fed into a walking beam furnace and heated uniformly to 2,190 degrees Fahrenheit. As soon as they leave the furnace, the billets pass through a descaling station, where ultra-high pressure water jets reaching 240 bar blast away the entire layer of surface scale. The glowing steel then enters a continuous series of roughing and finishing mills. Here, dozens of massive cast steel rollers repeatedly compress and stretch the red-hot material at speeds of up to 25 meters per second. With every pass through the rollers, the steel becomes thinner and longer. Under this immense pressure, the material is transformed into different products according to market demand. Slabs become steel plates or hot-rolled coils, billets are rolled into steel bars or wire rod, while larger blooms are formed into structural beams or heavy-duty rails. An automated laser measurement system continuously controls the roll gap, keeping thickness deviations below 15 microns and completing the steel's remarkable journey of rebirth. As the glowing steel strips leave the rolling mill, they are immediately cooled under controlled conditions by high-pressure spray systems that create a dense white mist. This rapidly but evenly lowers the temperature to prevent cracking, while powerful industrial fans blast air across the steel to preserve its crystalline structure. Once the temperature has fallen, ultrasonic sensors, high-resolution cameras, and mechanical testing equipment work together to detect everything from hidden cracks to the material's tensile strength. Steel strips that pass inspection are then tightly wound into massive finished coils, stamped as approved, and transferred directly to storage, ready to serve hundreds of industries. In the end, what once seemed like nothing more than a worn-out vehicle is given an entirely new life through modern recycling technology. Steel, aluminum, copper, rubber, glass, and countless valuable components are recovered, separated, and returned to the production chain, eventually becoming new buildings, everyday products, and even the next generation of automobiles. This is more than simply turning waste into resources. It is a remarkable circular system where mechanical power, precision technology, and environmental responsibility work together. Which stage of this automotive rebirth impressed you the most? Share your thoughts in the comments, and don't forget to subscribe to Factron Process for more incredible journeys inside the world's most fascinating industrial processes.